Welcome back to the deep dive. Today, we're tackling a really key shift in, well, enterprise AV infrastructure.
Yeah, the move away from traditional hardware switching.
Exactly. It's all about audio-video over IP, or AVoIP. And we're doing a deep analysis of one specific piece of gear, the Kramer KDS-100EN AVoIP encoder. We've got the product specs right here.
Right. And this encoder, the KDS-100EN, it's basically an advanced transmitter. It takes, high-quality 4K video at 60 hertz
Okay.
and streams it across a standard IP network. Could be copper, could be fiber. It's built for flexibility, especially in, really big setups.
So it's not just swapping out an HDMI cable, is it? This is more fundamental.
Oh, absolutely. The idea is to replace those big, complex, often proprietary matrix switchers with something based on standard IT tech. Something scalable.
Which brings us to scalability. The sources paint this as, well, super robust and designed for massive installations.
That's the key takeaway. Think environments where you need to manage maybe hundreds, or the specs even say up to 1,000 video feeds reliably.
1,000. Okay. So our mission today is clear. Unpack the tech specs, figure out how it handles that massive scale, look at integration, latency, security, all the critical stuff.
And then we'll touch on the commercial side too. The seller, the pricing, the whole package.
Perfect. Let's get started. All right, first things first, what's the KDS-100EN actually doing at its core? It takes the HDMI in.
Right. It encodes that HDMI signal, the 4K video feed.
Yeah.
But it's doing more than just the picture.
Okay.
It also grabs and sends control signals over the same network path. Things like, IR for remote controls or RS-232 for serial commands, even CEC for TV control.
Ah, so you can manage the connected display or source device remotely.
Exactly. Change volume, switch inputs, power on-off, all through the network. That integration, that unified control, it saves a ton of hassle in big installs.
Right. Managing controls separately is often a real pain point, but that scale you mentioned earlier, up to 1,000 sources.
Yeah, that number really jumps out.
That's immense. When you're dealing with that many feeds, the management savings must be the main driver, surely.
It's a huge part of it. Think about the old way. Massive racks of matrix switchers, tons of copper, lots of physical points of failure. Moving to AVoIP like this means you're managing connections via software over standard network gear. It drastically cuts down the physical complexity and potential hardware headaches.
And that explains the target markets mentioned in the sources. You said large education campuses, enterprise.
And crucially, defense and homeland security facilities.
Yeah.
Places where reliability is just paramount. Failure isn't really an option.
Makes sense. So for those critical environments, the video quality needs to be top-notch too. Let's get specific on the resolution.
Okay. So the maximum input it can handle, and also output locally, is 3840 by 2160 at 60 hertz. And importantly, that's with 4.4 chroma subsampling.
Full color, basically. No compression on the input side.
Right. Pristine signal going in.
But what about when it actually streams over the network? There's usually a trade-off there, isn't there, for bandwidth?
There is. And this is where the KDS-100 makes a, let's say, strategic choice. The maximum streaming resolution is still 38840 by 2160 at 60 hertz.
Still 4K 60.
But the color space drops slightly to 4.2.2.
Okay, 4.2.2. Explain that difference. Why is that acceptable, especially in, say, a security control room?
Well, 4.2.2 reduces the color information compared to 4.4.4. It halves the chroma resolution horizontally. But for most monitoring tasks, like watching security feeds or presentations, the human eye is much more sensitive to brightness and detail, the luma, than it is to those subtle color shifts. So you retain excellent clarity. Motion looks smooth because it's still 60 hertz.
Right.
But you significantly reduce the required bandwidth. That's the key.
Yeah.
It makes streaming high-res video over standard networks feasible without completely overwhelming them.
And it uses standard compression codecs?
Yes, H.264 and H.265. Open standards, which is good for compatibility and, not getting locked into one vendor's ecosystem down the line.
Okay, so you've got this potentially massive system, streaming high-res video using efficient compression. How does it actually perform on the network? That leads to two big questions, especially for those defense or security buyers. Is it fast enough? And does it kill the existing network?
Good questions. The sources address both. Latency, the delay, is quoted at around 40 milliseconds.
40 milos. Is that considered low?
For this kind of networked video distribution, yeah, that's generally considered quite good. Low enough for monitoring, presentations, command and control type stuff. Maybe not for real-time gaming, but fine for its intended use.
Got it. And the network load?
It operates within a pretty wide bitrate range. The sources say 1 to 60 megabits per second.
Okay, 1 to 60 megaps. That gives administrators some control, right? Balancing quality versus network impact.
Exactly. And that flexibility ties into Kramer's big claim here, that this KDS-100 line is efficient enough to run on existing 1 gigabit Ethernet networks.
The standard 1GE networks most places already have.
Right. They specifically say there's no need for complex IP packet prioritization, like quality of service or QoS configurations that often come with high bandwidth video.
That sounds appealing. Almost too easy for a busy campus network running data, voice, and potentially hundreds of these 4K streams. How realistic is that no QoS needed claim?
That's always the practical question, isn't it? I think the logic is that even at its peak, 60 millipedes for a 4K stream using H.265 is relatively low compared to, say, uncompressed video over IP, which needs much more bandwidth.
Right, those systems often demand 10GE networks.
Exactly. So the argument is that the KDS-100's traffic behaves more like regular data traffic, allowing IT teams to integrate it onto the existing 1GE infrastructure without needing a dedicated video network or massive upgrades. That's the cost-saving angle.
Okay, that makes sense. Stick with the familiar 1GE. Let's look at the actual box. What are the physical connections? We know HDMI input.
Yep, one HDMI input, but it also has professional audio handling, balanced analog audio in and out.
On those little screw terminals.
Yeah, 5-pin terminal blocks, standard for Pro AV installs, much more secure and reliable for long runs than, say, consumer RCA jacks.
Good point. And what about outputs besides the network stream? Any flexibility there?
Quite a bit, actually. There's an HDMI loop-through port.
Ah, so you can plug in a local monitor right at the source.
Precisely. Used for confidence monitoring or local viewing. And it has that dedicated fiber port, too, using a standard LC connector. Supports common fiber standards for going really long distances.
Okay. Copper and fiber options covered. Anything else on flexibility?
Yeah, the audio handling is versatile. You can embed that analog audio input onto the IP stream, or you can de-embed audio from the IP stream back to the analog output on the decoder side. Useful for mixing different audio sources and destinations.
All right. So flexible hardware. But given the target market's defense, Homeland Security, we absolutely have to talk security. This can't just be plug and play with no protection.
No way. Security is clearly a major focus. The documentation states the KDS-100 devices comply with IT security requirements.
Like what, specifically?
They mention support for 802.1x authentication.
Network access control, so only authorized devices get on the network.
Right. And HTTPS TLS encryption for secure web management and control traffic. They even mention OWASP 10 compliance.
Which means they paid attention to common web application vulnerabilities in the device's management interface.
Correct. It shows a focus on hardening the device itself.
And one more acronym that's crucial for government buyers.
TAA compliance. The sources state it's TAA compliant.
Meaning it meets U.S. government sourcing rules, often related to where it's manufactured. Absolutely essential for selling into federal agencies.
Definitely table stakes for that market.
Okay, so we've got a technically solid, secure, scalable encoder designed for tough environments. Let's shift gears now and look at the business side. Where do you buy it, and what's the value proposition?
The source material we looked at really highlights the seller, HDTV Supply.
Right. What do they say about them?
They emphasize their history certified since 2003, so over 20 years in business, and position themselves as a strategic partner of Kramer.
Setting themselves up as specialists for this kind of gear. Makes sense. Okay, the bottom line, what does this thing cost?
The manufacturer's suggested retail price, the MSRP, is listed at $1,800.
Okay, $1,800, that's enterprise pricing.
It is, but the seller, HDTV Supply, has it listed currently at $4,440.
Ah, so a pretty decent markdown already, about 20% off MSRP.
Yeah, a significant saving right off the bat.
Especially if you're buying, say, dozens or hundreds for a large deployment.
Exactly. And they sweeten the deal even further. There's an additional discount mentioned.
Oh, yeah.
Yep, an extra 10% off if you use the code 10% off at checkout.
Okay, so that $1,440 price drops even lower. That starts to add up significantly on a big project.
For sure. Those multi-unit purchases are where these discounts really make a difference to the project budget.
Beyond the price, are there other purchase benefits mentioned? Things that matter to enterprise buyers?
Well, there's free USA shipping, which is nice, but the big one is the warranty.
How long?
Kramer provides a 7-year warranty on this KDS-100EN encoder.
7 years. Wow, in the tech world, that's That's practically forever.
It really is.
Yeah.
A 7-year warranty on network hardware like this signaled a huge amount of confidence from the manufacturer in its reliability and longevity.
Yeah, that kind of assurance is critical when you're making a big capital investment, especially for systems that need to run 2047 in mission-critical places. That warranty really changes the risk calculation.
Absolutely. It speaks directly to the long-term value proposition. Hashtag tag outro. So wrapping it all up, what is the KDS-100EN? It's clearly a robust, secure, and highly scalable AVoIP encoder. It's TAA compliant, aimed squarely at those large demanding environments like campuses, government, defense.
Right.
And the key seems to be balancing those advanced 4K 60 capabilities and security features with relative simplicity in deployment. The claim is you can leverage existing 1GE networks.
Avoiding costly network overhauls.
Exactly. And backed by that really long 7-year warranty, the focus shifts towards reliability and long-term operational costs.
Which brings us neatly to that whole total cost of ownership idea, the TCO. It's always huge in enterprise decisions. With the low bit rates, the promise of using existing 1GE networks, this Kramer unit is definitely positioned as being cost-effective over its lifespan. So, here's the final thought, the question maybe to leave you, our listeners, with. You've got this unit price, let's say around $1,300 after all the discounts, backed by an impressive 7-year warranty. Does that long-term reliability and potential ease of management on existing networks truly outweigh that initial, still significant price tag? Or does the sheer complexity of actually managing, 1,000 video endpoints inevitably bring hidden costs and challenges, no matter how efficient the encoder itself is?
It's that classic battle, upfront cost versus predicted long-term savings and simplicity, especially at scale.
Something to definitely mull over if you're planning a large AVoIP rollout. Is the promise of simplicity over 7+ years worth the investment today?
A good question to ponder. Always layers to peel back with infrastructure tech.
Yeah, absolutely. Well, that's all the time we have for this deep dive. Thanks for joining us.
Thanks for listening.
We'll see you next time.